In part B, we want to graph some exponential and logarithmic functions. What might be helpful when you want to graph something that you don't know how to graph is to set up a little XY table and just pick a couple points. So the first point I would pick would be 0, and then just calculate what's y. It would be 2 to the 0. Well, anything to the 0 power is 1. That means that my y-intercept is going to be here at 1. And maybe we pick another point, 1. Y equals 2 to the first power. That would be 2. So that's the point 1, 2. And maybe a third point at negative 1. If y is 2 to the negative 1 power, that would give us a value of 1/2. So when x is negative 1, y is 1/2. And this should hopefully be enough for you to remember that the exponential growth curve starts low and then grows exponentially. This has a y-intercept at 1. The asymptote is the x-axis. That is the horizontal line, y equals 0. If we were thinking about domain and range, domain, all the x values that can be used, that would be all real numbers. However, for the range, the curve stays above the x-axis, so that means all of the y values will have to be greater than 0. Moving on to y equals 2 to the x minus 1, because that minus 1 is outside of the parent function 2 to the x, what it's going to do is take every single one of those points, those ones that we just graphed at 1/2 and 1 and 2, and we're going to subtract 1 from each of those values. So we can literally just take each of these points and drop them down 1 unit. So 2 drops down to 1, 1 drops down to 0, that 1/2 drops down to negative 1/2. And in fact, even our asymptote goes from being on the x-axis, down 1, to being on this line at y equals negative 1. But the curve stays up above that, starting low and growing exponentially. If you were asked about the domain and range, the domain, again, is all the x values that we can use, and that will be all real numbers. However, the range this time, our curve stays above this asymptote at y equals negative 1. So that means all the y values are going to be greater than negative 1. When it comes to graphing logarithms, it's a slightly different story. What I've said all along is that one of the most important things that you can learn about logarithms to help you with logarithms is to be able to change them into exponential equations. So if I have that y is equal to the log of x, I can rewrite that as having the same base but switching the x and y around. So instead of being log base 2 of x, I would rewrite that as 2 to the y equals x. Then when I set up my table and I pick 0, I'm not going to pick 0 for x, I'm going to pick 0 for y, because then x will be 2 to the y power, 0. And anything to the 0 is 1. When I pick 1, that's going to go as the power, 2 to the first power, would be 2. And when I pick negative 1, that would be 2 to the negative 1, which is 1/2. Plotting these points, 1, 0 is the x-intercept. 2, 1 over 2 and up 1, and 1/2 negative 1. This should be enough to remind us that the logarithm curve is the inverse of the exponential curve. So it's also going to start very close to an axis and then grow. That y-axis this time is going to be not our horizontal but our vertical axis, our vertical asymptote. And that's the equation is x equals 0. Thinking about domains and ranges, this time we can't use negative x values. This curve stays to the right of the y-axis. That means that all of the x values have to be greater than 0. As far as the range is concerned, this curve will go down to a negative infinity, and it'll go all the way up to positive infinity. So now the range is all real numbers. In problem number 4, when I want to graph y equals log base 2 of x minus 1, things are going to be very similar to the other logarithm curve, except now I have this minus 1 inside of the parentheses. It's not outside of the function, now it's inside of that parent function. And what that's going to do is to shift everything to the right 1 unit. Because we think about, well, that asymptote used to be when x equals 0. In the parent function, when that x was 0, we end up with a vertical asymptote. Now, I'm going to want my vertical asymptote to happen when x minus 1 is equal to 0. So that means it's going to happen at x equals positive 1. The curve is still going to have the same shape, it's just going to get shifted over a little bit. That 1 unit, in fact. Instead of having an x-intercept at 1, I'm going to shift it to the right 1, and now it's at 2. Instead of having the point negative, or 1/2 negative 1, I'm going to shift it to the right 1 unit. So now it'll be at 1.5 negative 1. And instead of being at 2, 1, I'm going to shift it over to 3, 1. And it'll still keep that same logarithmic curve where it starts close to the asymptote and then curves away. In this case, the domain, all the x values are going to stay to the right of that positive 1, so x has to be greater than 1. And as far as the range is concerned, again, it's going to go up all the way and down all the way, so the range is all real numbers.